Very good morning. Today, actually, I have completed the most of the laboratory programs related to your 8085, and but I think that there will be a lots of assembly language programming for you to practice, because with this programming concept you will be able to answer most of the competitive type exams, like your mostly preferable gate, right? So in your gate exam, uh, very large amount of marks questions are coming from your microprocessor part, right? So and there a very conceptual knowledge is required to run each and every program and to execute the output, right? So for that purpose, I think that you should practice different types of program in your own way, in a various by using the various types of instructions, not only the no similar instructions that I am using. And I think that from this second year you should have a practice of it, specifically this microprocessor and microcontroller, to crack gate very much easily, because the most of the questions come from microprocessor, from communication, from analog and digital communication preferably. And in the next semester that I will teach you the coding theory, information and coding theory, and this is a very important part. And from that section a very simple problems are coming, but in a complex way, right? So for that, you today I will teach you the another important microprocessor programming, assembly language programming, that is the program for finding the number of the number of negative numbers in the series, right? You have already came to know the concept of positive number, negative number, right? And in the morning I have already shared with you a clue, that is for executing this program you should have the knowledge of flag register, because there is a single flag, that is sign flag, right? And sign flag is denoted by the bit D7, that is the MSB. I have already mentioned this word, right? This MSB, that is the most significant bit, okay? So you should have the knowledge that whether it is 1 it will be a negative number, and whether it is 0 then it will be a positive number. So for that purpose you have to use the rotating instructions and the branching instructions. And what type of branching instructions? That is the jump if carry or jump if not carry, right? For checking bit whether it is 1 or 0. Okay, so for that programming I have already shared these flowchart for you, and please prepare your lab copy accordingly from this flowchart and the programming code, and also the input output, and not last but not the least, the conclusion, right? Okay, so this block I have already kept it blank because it is for you to fill the blank, and what will be the portion that should be incorporated in this blank box, right? Okay, so this is your start button, okay, and there is a the conditional box, right? But before that, this blank box is there, and what will be your answer? I think the most of you have able to answer that what will be the portion that will be written into this blank box. What is that? This is nothing but initialization, right? So these box I have already shared several types of programs with in a similar way, and if you go through very thoroughly that, you will see that most of the things are similar, right? But in a different way. You have to assemble that according to your logic, nothing else, nothing complexity behind that, right? So please, if you check all the flowchart, most of the things are similar, most of the things, right? So after start there will be initialization box, so that's why I have kept it blank. And what will you write in this initialization box? Nothing but the initialization part, right? Okay, so what we are doing in the initialization part, because our programming is the finding the number of negative numbers, right? Okay, so at first I have to set the pointer from that location, the memory location is started, that I have already shared with you the program, right? And the pointer is 9001, the beginning memory location is 9001. So this is also initialization part, that will be written over there, right? And the another one I have already shared in the question, that the series of numbers, whether there is 4 numbers, whether there is 10 numbers, whether there are 100 numbers, that according to you, but that series, that is the length of the series, that should be initialized, right? And after that you have to set the counter value with that length of the series, and you have to decrement the counter accordingly, okay? Because all these processes are well known to you, because this is repeated once again. Okay, and the another number is another counter I have to use. What is the number of counter? That concept you have already used the program where it was the counting the number of ones and number of zeros, right? So the step whether you are getting the number of ones, some register will be there, and the value of the register will be incremented accordingly by getting the number of ones or number of zeros. So here there must be a counter that will be incremented after getting the negative number. Okay, so here two counter will be used. One will be incremented, one will be decremented obviously the counter, that is the length of the series, and incremented obviously the register that will count the number of negative numbers. If firstly I am getting the first negative number, so it is 1. Secondly, I am getting the another negative number, so it will be incremented by another 1, that is 2. And if I am getting the third number, then it will be accordingly to 3, and it will be so on, right? And the another pointer that should be initialized, that the beginning memory location from where the data will be coming from the memory location, right? Okay, so in the initialization part I will write, firstly write down the count of negative numbers, that is equal to 0. That register I will set, it's a 0 value, okay? And what is our pointer? That is the beginning memory location that I have already written in the question, that is 9001, right? And the another initialization, that is your count. So the count is equal to, I have already shared in the question, that is 9000. Okay, the number of series, the number of the length of the series that is stored in the memory location, that is 9000. So from 9000 the value will be coming to some register, and that will be acting as your counter, right? Okay. So this is your total initialization part, right? Okay, then we have to check whether the MSB means the sign flag is 0 or 1. Okay, so is MSB equal to 1? I am just putting the condition, but you have to put the instruction according to the condition, right? So if MSB equal to 1, then there will be two outlets. One is yes, one is no. If it is yes, that means it's a negative number. So the count of negative number equal to count plus 1. So initially the count is 0, and 0 is 0 plus 1, that will be equal to 1, and that will be continued in the loop until and unless the length of the series is decremented to the 0, right? Okay, and if it is no, then we have to check the another pointer, another location. Firstly I am checking the 9001, and then I have to check the 9002 value, right? Okay, so then if it is known, then we will go to the next location, and where the pointer will be equal to pointer plus 1, right? So if we are in the location 9001, but in this step we will be in the location 9002, but for that purpose you have to use the instruction to increment the location that you have already used in a several program, right, for several times. Okay, and obviously the count is equal to count minus 1, because we have already checked the fourth number, then it's a third number, second number, first number, so it will be decremented accordingly, right? And if the counter is 0, then yes, the program is over, is end. Then the value, the number of count of negative numbers will be stored in the location 9100, right? Because the program is complete, the end. And if it is not 0, then again I have to check the overall process that we calculated from the checking portion, that is MSB equal to 1, right? Okay, so this is your total flow chart for your counting the or finding the number of negative numbers in the series. And it's a very important program, whatever you can say, and it's a very useful for your GATE exam. Whatever programs I have already taught in your class, in your online mode, all will be helpful to you for preparing yourself for your competitive exam like your GATE exam. And for that, please go through the instruction set thoroughly, the type of the instructions, the logic of the instructions, and the implementation way out of the instructions, right? Okay, now let's come to the programming part and see that how according to the flow chart the program will be executed, right? Okay. I think it's visible. I think it's visible, right? Okay. Yes. So first, from where we can start? From where we can start? We can start it from the initialization part, right? And what are the initialization part? For loading the length of the series, for initializing the counter C, and for initialization some another register with the initial value 00, and that will count the number of negative numbers, right? Okay, so first of all, I have already told in the question that the length of the series will be from the location 9000, right? So what will be your first instruction? The first instruction will be LDA 9000. And what does it mean? Please note it down, because I will not write the details of the instruction, because I have already explained the repetitive way, in a repetitive way. So today I will not write the explaining the instructions, but I am writing, I am telling verbally. So please listen me carefully, and if possible, please write it down. LD 9000 means the length, load the length of the series in the accumulator, because the length of the series is stored in the location 9000, right? Okay, so this will be your LDA 9000, right? Okay, now the initialize the register C as the counter value with the initial value of the length of the series. So whatever value we are getting from this location 9000, that is the length of the series, and that will be acting as the counter value, right? And this counter value will be stored in some register, right? And we are taking is at it as move C comma A, because I am designing the register C as a counter. Clear? So whatever value in the accumulator, that will be transferred to your register C, right? So second initialization is complete, and third initialization is that register that will store the number of negative numbers. And what are the register? I am taking it as B register with the initial value that is 00. So the instruction is changed, that is MVI, move immediate, because the operand is 8-bit data. Clear? Okay, so this is your initialization part, that box in the flowchart, in the beginning box, right? Okay, so now we will continue the next part by adding the loop, right? By adding the next part. Okay, so what will be your next part? Initialize the memory pointer, right? From where the data will be coming through. So what was that? This was 9001. So I have to store the data. So this will be your LXIH 9001. HL pair, right? We are using HL pair. Clear? So initialize the memory pointer, and that will be incremented parallelly. Okay. Okay, so LXIH 9001, right? So this is the first memory location from where the first data will be coming, right? Okay, so now we are at the stage where we will take the first data for checking that whether the MSB is 1 or not, right? So for that purpose, we have to take the data from this location to the accumulator. And what will be the instruction? The instruction will be obviously move. And what will be your operand? I think is answerable, that is A comma M, right? And what is M? M is nothing but the first memory location. Clear? So it is nothing but load the data from the series to the accumulator. Clear? Okay. Now we have to rotate the data to check that whether the carry bit is there or not, whether the MSB is 1 or not. And for that purpose, we will use RAL and RAR, right? Because this is with carry, right? Okay, so we will use the instruction RAL. And what is that? This is nothing but the rotate left through the carry bit to check whether the, I am writing it over here, rotate left through carry to check whether MSB equal to 1 or not. Clear? Okay, so there will be two conditions, if carry, if not carry, right? But we will use the instruction not carry because this is easy. The next instruction will be jump if not carry, right? Jump if not carry, if carry or if not carry. So jump if not carry, then we will go to somewhere, and jump if carry, then we'll go to somewhere. And if it is not carry, then I am putting some indicator. Jump if not carry, I will show it later. But if it is carry, carry means we are getting the negative number, right? So increment the negative count. Obviously increment the negative count. Jump if not carry means there is no negative number. Jump if carry means there is a negative number, because there is two outlet will be there. One is yes, one is no. So if it is yes, if it is yes, then count will be equal to count plus 1. So the next line will be INRB, right? Jump if not carry, then we will go somewhere. But if it is carry, then we are getting the negative number, and negative number means the count will be incremented, count will be updated, and whether the count where the count is stored with the initial value, that is 00 in the register B, right? So it will be your INR-B, right? But if it is not carry, where we will go? We will go to the next location, that is pointer equal to pointer plus 1. Right, but the location is stored in your HL pair, and this will be incremented, right? So how we can increment that? By using INXH. Simple. So if it is not carry, we will go to the location, that is INXH, and here the same indicator will be there. Clear? I think no question, no doubt. Okay, now the logic is set, and this is incremented internally, but how long it will be incremented? Until and unless the counter is decremented. So for that purpose, I have to use that same instruction, that is DCRC, because we have set the counter C for counting the number of length from the series, right? So decrement C means the counter is 0 or not 0. If it is 0, then we will exit the loop, and if it is not 0, then we will again continue in the loop, right? Okay, so decrement C means next the conditional instruction will be there, that is jump if not 0. So if it is not 0, there will be some way out, and if it is 0, there will be some way out. Okay, so if it is not 0, we will go to that location from where the data is coming, right? And where the data is coming, this portion, move a comma M. So there I am placing the same indicator, that is loop, right? And if it is 0, then what I have said in the flow chart, that is if it is 0, then the total count of the negative numbers will be stored in the location 9100, right? Okay, so the total data is where? The total data is in the register B, because we have set the register B for your counting the number of negative numbers, right? So if it is 0, the total value will be transferred to your accumulator. Simple. So move A comma B. So the result from the register B will be coming to the accumulator. Simple. And we have to show the result. Now it will be STA, and what is the location for our showing location? That is 9100, right? And again it will be your halt. think it's clear. And this is your total program of your finding the negative numbers. I think I have explained each and every instruction once again. So please go through this. If any questions, please let me know. And we will continue our programming session by tomorrow with a new program. Right? So till now, all the best.